So today we're going to go over the mass percent and empirical formula assessment, and we're going to kind of talk about how do we go through the thought process, how do we approach these problems so we can be able to do it for AP exams. So all of these questions that you see here on this assessment are AP level questions. It's what you would see on a free response question. So you don't have to worry about not using a calculator. You can use a calculator all day long on this. And I would say as far as timing goes, you want to spend no more than about 5 to 7 minutes on these to be able to work on your time management skills, okay? So we're going to look at the very first question and kind of go through it together, all right? So let's first read that question, understand what it's saying and what information it's giving us, okay? So it says, an organic compound was synthesized and found to contain only carbon, hydrogen, and oxygen. All right, so let's pick apart and understand what that's saying. We have some sort of compound that has C's, H's, and O's, but we don't know the mole-to-mole ratios of those particular elements in that compound. And so that's probably what we're going to analyze, okay? It was observed that when 0.25 grams sample of the compound, so that means they took 0.25 grams of this entire thing. All right, so that's our sample. And it was burned. So most of the time when we're doing empirical and molecular formula, we take a sample and we burn it. And we know that based upon our reactions that we've done, that if we take things that are carbon and hydrogen based and we burn it, meaning we react it with O2, what are the two products we get, guys? Carbon dioxide, right? Our combustion reactions, carbon dioxide and what else? Water, right? So they're taking this sample and burning it, right? And so do you see that it produces, so if I take it and burn it, meaning reacting it with O2, is going to produce 0.433 grams of CO2, and it's also going to produce 0.238 grams of H2O. So do you see how you're basically taking this unknown sample and you're reacting it with oxygen and you're going to get these two products, okay? So we want to be able to do a number of things, all right? Part A wants us to find the empirical formula, okay? Now, this is different from what you've been doing in your practice, right? Because what was given to you guys in the practice? The mass percents, right? Do we have mass percents here? No, we have something else. We have information, how much is of that total sample, we have how much CO2 we have, and we have how much H2O we have. That's it. So we have to somehow use this information to help find our empirical formula. Well, think about our process for empirical formula. We have mass percents, and we do what with those mass percents?
Convert it to grams.
Very good. We convert to grams, right? And then we take that grams and we do what with that? Convert it to moles, right? So we can kind of bypass the percentage by taking grams and convert to moles, right? But here's our problem. CO2 is not in this compound. Just carbon is in this compound. Just hydrogen is in this compound. And just oxygen is in this compound, right? So somehow we have to take this information and we have to pull just the carbon out of it. So this is where the dimensional analysis comes into play, right? Remember how in the practice problems you guys had a whole compound and you were pulling just one thing out of it? That's the point of that practice. We're actually applying that here, okay? Now here's a very important side note that you need to realize. This C, the carbon in CO2, is coming from here. The hydrogen from H2O is coming from here. But if you have a compound that has oxygen in it, this oxygen and this oxygen does not come from here. Where do you think it comes from instead?
O2.
The O2, right? So I cannot use this to find this oxygen because that's not where it comes from. I can't use this to find this oxygen because that's not where it comes from, okay? So that is very important to realize. This oxygen is coming from here, this oxygen is coming here, so I won't be able to do dimensional analysis to find oxygen. I'll have to do something else, okay? So let's start step 1. We are going to take this information and pull just carbon's moles out, okay? So I'm going to take 0.433 grams of CO2. Then I'm going to have to get into moles, right? So 44 grams of CO2 is for every 1 mole of CO2. Now what do you think the next step is going to be if I just want carbon out of that?
1 mole of CO2 is 1 mole of carbon.
Very good. 1 mole of CO2 is equal to 1 mole of carbon. And do you see how that gets rid of grams CO2? It gets rid of moles CO2, and it leaves me with just moles of carbon, which is where I need to be in order to be able to do empirical formula, right? So we're going to go through and do this math. I don't have my calculator with me. Will someone plug that in for me, please? Okay, so 0.0098 moles of carbon. So do you see I found how many moles of carbon out of this compound reacted, right? Now we're going to do the same idea where you need to pull away hydrogen, right? And so to do that, I'm going to use the H2O. So I'm going to start with 0.238 grams of H2O. And we're going to get into moles first, right? So 18 grams of H2O is equal to 1 mole of H2O. Then just like before, we're going to work a mole-to-mole ratio, right? So I want to get rid of H2O, so that's going to go on the bottom. 1 mole of H2O has how many hydrogens in it, guys? 2. Very good. Y'all are doing great with this. So now, grams of H2O is gone, moles of H2O is gone, and I'm left with moles of hydrogen, which is what we need for the empirical formula. We're going to go through that math. Has anyone calculated it yet? 0.026 moles of hydrogen. Now, we have carbon, we have hydrogen. The only thing that's left is for us to do oxygen. Now remember I said that I can't use these 2 things to find oxygen. So what are some ideas as to what I can do to find oxygen?
The ratios. So like for every 2 hydrogen.
That's a good thought. Let me give you a hint. I'm going to have to use this information somehow, okay? Due to the conservation of mass, 0.25 grams of these reacted. Well, total of carbon plus oxygen, or plus hydrogen, plus whatever oxygen was reacted here, they also have to equal up to be 0.25 grams, right? So what I'm going to do is I'm going to figure out how many grams this guy is, how many grams this guy is, and then I'm going to subtract those values from our original starting amount. If I subtract those 2 from the original starting amount, then that will tell me how many grams of oxygen we have left over that reacted. And if I know how many grams, I can very easily convert to moles of oxygen. Okay, so that's the process that you need to do in order to find oxygen whenever you have these type problems. Okay, so I'm going to go over here to the side and I'm going to work in green so we don't get things mixed up. And I'm going to say how many moles of carbon or how many grams of carbon do we have? So we have 0.0098 moles of carbon. And we're going to convert that to grams. So I'm just going to say 1 mole of carbon is equal to 12 grams of carbon. Does someone do that math for me, please?
0.1176.
0.1176 grams of carbon. And we're going to do the same process for the hydrogen. So 0.026 moles of hydrogen. 1 mole of hydrogen is equal to 1 gram of hydrogen. So that's pretty easy, 0.026 grams of hydrogen. Now, what this is telling me, all right, let's understand why we're doing this. I couldn't use these to find oxygen. So I had to figure out how many grams of carbon came out of here. How many grams of hydrogen came out of here. And then the remaining is going to be the grams of oxygen that came from the sample. So if we take 0.25, which is the entire thing, and we subtract 0.1176, and we also subtract 0.026, we should get how many grams of oxygen reacted. So what is that number? 0.1064. Do we understand why we're doing this step? Where that's coming from? Why that's important? Okay. Well, now that we know information about our oxygen now, we can go back here and keep working for our empirical formula. All right? So I'm going to go back to black since we're working with that. So I'm going to say 0.1064 grams of oxygen. We have to get into moles. So that's going to be 16 grams of oxygen is equal to 1 mole of oxygen. And what's that number? .00667. All right, moles of oxygen. Now that we've done all of this, we're in a place where we're very familiar to be able to find empirical formula. So we have moles of each compound, each element within the compound. So our next step is going to be divide by the smallest number. Okay, so I see that the smallest number here is 0.0067. So I'm going to divide all these by 0.0067. See, this one will be 1. So we have 1 oxygen. How many carbons will we get out of that?
1.46, so 1.5.
We'll call that 1.5. And then what about the next one?
Oh, it's 3.88.
Okay, we'll call that 4. Let's see. Carbon, hydrogen. So notice how if I were to look at my multiple ratios, this is kind of like in the middle, right? So what we have to do is actually multiply all of those by 2. So therefore, our empirical formula is going to be C3H8O2. And that will be our empirical formula, our answer for letter A. You guys got any questions?